Welcome, everyone. Thanks for joining today's Joints Aklivity and AWS Tech Deep Dive on operationalizing Amazon MSK. We've got a focused 60 minutes, 45 of which will be split across contents, focusing on MSK fundamentals, the operational layer that sits on top, and a reference architecture with a live demo. Then we'll leave around 15 or so minutes at the end for Q&A. If you have any questions, drop them in the panel at any time. We'll work through them at the end. Quick intros around the panel, then straight into framing. My name is Daniel Tokyanov. I'm the CEO and co-founder of Aklivity. At Aklivity, our expertise is on streaming native API infrastructure, and we're ultimately on a mission to bring an operational and governance layer to real-time data infrastructure within the enterprise. Based here in not-so-sunny California, just south of San Francisco. I'll hand it over to John for an intro on his end.
Hi, everyone. My name is John Fallows. I'm CTO and co-founder, along with Leonid here at Aklivity. I have a strong background in web, mobile, and protocols, and I helped to create the WebSocket standard part of HTML5.
Shubham?
Hello, everyone. My name is Shubham Rakshit. I'm a senior streaming solution architect in AWS. What it means is that I work with customers to help building, modernizing, and performance tuning streaming architectures. And I'm based in UK.
Cool. So just a little bit of framing. So Apache Kafka was released over 15 years ago, and it's been a key enabler for processing and taming real-time data. Born inside LinkedIn's data centers, it's historically been notoriously difficult to deploy and manage. And this is where managed Kafka services such as Amazon MSK comes in. MSK removes the broker-level operational burden, so things like patching, scaling, networking, IAM. But while that solves the infrastructure problem, it doesn't solve the organizational problem. As MSK adoption spreads across teams and partners, 4 new gaps surface. First, self-service access for application teams. Second, secure external access for partners and non-AWS clients. Third is governance and policy enforcement across topics, schemas, producers, and consumers. And then fourth is observability into who's consuming what. So most teams hit these 4 capabilities around the same time in their MSK journey. Usually it's somewhere between 10 and 20 consuming teams, or when the first external partner asks for Kafka data. The good news is there's a clean architectural pattern for handling all 4 without modifying MSK itself. That's what we'll spend most of our time on today. Shubham is going to start off with how MSK has evolved to handle the infrastructure side at scale. Then I'll come in with the operational layer. So Shubham, handing it over to you.
So as I mentioned, is work with customers. So when you talk to customers, the important aspect that matters most to customers is the 4 things. One is performance, cost, availability, and ease of use. So customers, from a performance standpoint, want the highest performance per unit of scaling, meaning each unit they add should deliver the maximum throughput. More performance with fewer resources is always the goal. Second is the cost. This one is straightforward, of course. Customers want the lowest overall cost for the streaming solution. They're looking at the total cost of ownership, not just the unit price, and every dollar saved matters at scale. Third is availability. Well, streaming workloads are often mission critical. So customers need a resilient infrastructure out of the box. And more importantly, they need the ability to easily build resilient applications on top of it without having to become a distributed system expert themselves. And finally is the ease of use. Time to value is everything. So customers want to get up and running fast with lower operational overhead and seamless connectivity to the rest of the application ecosystem. And when we talk about the streaming, Kafka stays the center stage. And we at AWS constantly innovating to ensure how to run Kafka better on AWS. And that's where Amazon MSK comes in, a fully managed, highly available, secure service for Apache Kafka. It eliminates the operational overhead. We just talked overhead. And furthermore, AWS is deeply committed to improving open source Apache Kafka. Let's look at some of the MSK benefits. First, it makes Kafka more secure, highly available, and accessible out of the box. Encryption, multi-AZ application across broker, and IAM integration come built in. Second, it drives a best practice through design, defaults, and automation. So you're not relying on tribal knowledge to configure your clusters correctly. Third, it lets developers to focus on building application and less on managing infrastructure. And the fourth, it also eliminates the necessity of right-sizing, scaling, or any kind of partition management. We have different flavors of Amazon MSK, and we'll talk about that. So Amazon MSK provides two different flavors of Kafka. One is the provisioned, another is serverless. And within provisioned, we have two types of broker. One is standard broker, another is express broker. So a very common question I get from customers is that how to choose what? What's the mental model looks like? And this is exactly what the choice between control and automation comes in. On the left, we have standard broker. This is used by customers who have deep Kafka expertise and need fine-grained control over broker configurations and storage. While standard brokers give you the control, while AWS still manages the underlying infrastructure. On the right-hand side, we have Amazon MSK serverless, and it's mostly used by teams who want to get started quickly without any Kafka management, zero Kafka management. There's no capacity planning required, no right-sizing of brokers required. You just create the cluster, create the topics, and start your application to read and write from those topics. This is best fitted for customers who are new to streaming or are new to Kafka. What you have learned is that most customers actually sit in between full control and full automation. And that's why you have Express Broker. Express brokers are designed for customers who value performance and elasticity, but also want to lower the operational control over Kafka. If you're operating a large-scale Kafka estate and want to faster scaling, zero storage management, and improved throughput, Express Broker is the right choice to do so. And we in AWS really believe that if you are starting with your Kafka workload on AWS, Express Broker is a good place to start your Kafka workloads. So what's the story of Express Broker? So to know that, let's go back to October 2022 when we released tiered storage. It was a phenomenal launch, and what happened is that allowed the MSK service to tier the storage layer. That means you can store the hot data in the EBS volume, and you can also actually offload the warm data or the cold data in some kind of remote storage. What tier storage solved, it reduced the cost of retaining data by 60%. And you can store the data as much as you want within the Kafka cluster. And it essentially solves the overall storage elasticity of Kafka. However, what it doesn't solve is it didn't address the storage management overhead. That means as a customer, you still need to think about how big EBS volumes you need, what's the provision storage throughput you require, and what configurations what are required for that. What if your disk gets full? You need to be aware of the disk capacity alerts that we provide. And then the configurations to move data from the EBS volumes to the tiered storage. So there is a bit of a storage management overhead still there, and that's a cognitive overload, and some cases there's an operational burden to some customers as well. We didn't solve the resource coupling. And what I mean by that is that the foreground traffic and the background traffic cannot be are still coupled together. So if there's some kind of background operations in Kafka, that can degrade and that can have an impact or degrade the producer consumers that talking to your Kafka cluster. Finally, it doesn't solve the compute elasticity problem. But the team went back and started thinking about that what if we eliminated the overall storage management overhead? There's no need of thinking about storage layer from a customer standpoint. That means the complete storage layer is managed, and you just start thinking about writing data to the Kafka clusters, and based on how much data you are reading or writing from the Kafka clusters, you'll be charged for that. And that means you don't need to think about EBS volume, provision storage throughput, all the configuration, disk capacity alerts, all of that. Zero. Second, what if we could decouple the resources within Kafka? That means that what if we could separate the background operations from the foreground traffic? And that means that even if there's some kind of partition rebalancing going on, even if, let's say, a broker went down and the disk failure happened, when Kafka comes back, there's some catch-up replication happening. That means you're still able to kind of catch up while you're doing that. It doesn't degrade or doesn't impact the overall client traffic. That's super important. Third is, what if you could optimize for compute elasticity? That means you could simply add more brokers to the Kafka clusters, and we can scale the cluster, we can scale the throughput of the clusters. And the fourth, what if we could actually take some of the best practices of Kafka as a default configuration to the class cluster, like totally baked in. So for example, the replication factor. Interestingly, what you have found is that many customers make mistakes with replication factors and with min-sync replica particularly, and that can cause an availability concerns. Then there are other configurations like networks, IO threads. And those configurations are granular to the level of what type of broker you're using and what size of broker you're using. So if you are operating a kind of a self-managed Kafka clusters and you are changing the broker type, you also need to think about changing those configurations of networks and IO threads to extract the performance out of the broker. And that means for every scaling, you need to make a change. And that's a kind of an operational burden over there. What if the cluster takes care of that so that even if you go from one broker to another, it automatically gets applied? And that's essentially four of these is the combination of what is Express Broker for Amazon MSK. What Express Broker deliver is 3 times the throughput of an Apache Kafka broker. Well, if you look at Kafka can provide a lot of high raw throughput. But the question is how the system will perform when it is under load or you lose a broker. You won't get the same raw throughput. It's hard for customers to think about what would be the sustained throughput of the cluster with specific broker type. So that means we are moving from a narrative of a raw throughput to a narrative of a sustained throughput. If we could give the customers an ability to think about if we use this particular broker type and which can give you a sustained throughput of, let's say, 15 megabytes per second, that means customers can do the sizing and capacity planning much easily. And that's what Express Broker provides you. Depending on what type of broker you're using, we provide the recommended throughput. And this is in our documentation. So imagine if you need to run a 180 megabyte per second of ingress throughut, all you need is a 3-broker M7G 2x large Kafka cluster. That's it. Now let's talk about one of the biggest operational pain points with Kafka, horizontal scaling. Well, here we have a cluster with 3 brokers and each holding 3 partitions. So when you need to scale out to 6 brokers, these partitions need to be redistributed. Now, with standard broker, this needs to be carefully orchestrated. The 3 things you need to manage. First, you need to ensure you have enough reserve bandwidth for the rebalancing. You need to carefully orchestrate the partition movement so it doesn't impact your applications. Also, you need to continuously monitor the throughput throughout the process so that you can readily adjust the plans if anything needs to be changed. On top of that, rebalancing can take hours. It's a variable time. And the duration is variable depending on data volume, partition sizes, and cluster load. And it is one of those operations definitely teams kind of hesitate to kind of get on a journey very often, and they delay it, which means they end up running an over-provisioned clusters just to avoid it. And this is exactly what Express Brokers change again. Express Broker are 20 times more elastic compared to standard brokers. And it can do this partition rebalancing way more faster, 20 times faster than that of a self-managed Kafka cluster, or even if you're using a standard broker. Well, in Express Broker, the storage layer is completely managed and it is decoupled from the brokers. So you have a complete decoupling of the brokers, compute, and storage. And in AWS, we have a shared responsibility model, and the shared responsibility model falls on the broker itself. That means you as a customer is responsible for choosing what type of broker is required. Whereas AWS takes care of spinning up those brokers and managing those brokers and upgrading those brokers, all of that. Another way, if you start thinking about it, because now that you don't need to manage the storage layer, the experience of Kafka becomes more stateless to you because we manage the state behind the scene. So if you need to start thinking about higher throughput capability in the Kafka clusters, all you need is to add more brokers to your Kafka clusters. That's it. Now, failures can happen. Well, and we should start thinking about how our systems behave when there is a failure. Now, when there's a failure of a particular broken node or so, the node comes back online and it starts serving traffic faster. Because you're able to decouple the resources within the Kafka clusters, that means when the broker comes up and doing a catch-up replication with existing replica partitions, it's not impacting the foreground traffic. And that means during that time, your applications are not impacted. Another way, your resilience is higher and your mean time to recovery is also lower. We have launched a capability called auto intelligent rebalancing that allows you to continuously monitor the resource imbalance within the Kafka clusters and do the automatic partition rebalancing without affecting the availability of the Kafka clusters. So what it will do, it will actually continuously monitor the resources within the Kafka clusters. And if you see there is a significant imbalance, then it will automatically move some of the partitions from one of the broker to the other brokers across the clusters. Secondly, when you scale out is a two-phase operation. Think about it. Like first, you need to add the number of brokers in the Kafka clusters, but you also need to do a partition rebalancing across all the newer set of brokers. Automated partition rebalancing will automatically actually rebalance the partitions across all the new set of brokers. You don't need to think about it. That means your scaling process becomes much more simplified. If you just scale the number of brokers, automatically the whole cluster will be redistributed. All the partition in the cluster will be redistributed across a new set of brokers. What happens when you scale back in? Well, when you scale back in, what is required to be done is that it needs to move the partitions from the other brokers to the brokers that will exist. That means you need to clear up or empty certain brokers in the Kafka cluster. So if you have a 6 broker Kafka clusters, it needs to empty 3 brokers from there, so that you have all the partitions in the first 3 brokers in the Kafka clusters, and it can then scale back in. It can reduce the number of brokers in the Kafka clusters. It's completely taken care of. What you have found is that this intelligent rebalancing is 180 times faster than standard brokers, and there's zero additional cost, and it provides a fully automated partition management without any third-party tool requirement like cruise control or so on. Just to put some numbers, we talked about, you get 3 times the more throughput per broker in MSK Express brokers. Your scaling is 20 times faster, means you can scale your Kafka cluster in minutes faster to respond to gradual increase in traffic. Your brokers can fail any point of time and in unprecedented scenarios, and that can happen. The question is how fast you can recover, and you can recover 90% faster compared to that of a standard broker or a self-managed Kafka cluster. And you can do a faster partition rebalancing, which is 180 times faster. And the last one is you also support 5 times the partition count per broker compared to that of a standard broker. This means If you have a partition-bound workload, you do not need to actually run a bigger a set of brokers just to contain all the partitions. So you can still run a smaller cluster with a less number of brokers, and while each broker can actually host more number of partitions. Effectively, it can reduce 50% of the cost. And the last one, the question is, if MSK Express is so good, how you can migrate to MSK Express? And that's what we have recently launched a capability. It's hot off the press of using MSK Replicator to support external Kafka clusters or Kafka protocol that allows you to move from the external Kafka clusters to Amazon MSK Express. This capability of MSK Replicator was already existing. Initially, it used to support in between two MSK clusters. Now we have also enhanced that to support external Kafka clusters as well. And it supports a bi-directional replication, actually. That means you can move the data across both the source and target and from the target to source. And it automatically takes care of the offset translations and replicate the topics and the data and the metadata associated with it. Your migration becomes very flexible. A big challenge with migration is that should you move this particular client A first or client B first? Because we support enhanced consumer group offset replication that allows you to actually migrate the producers and consumers in any order, and you do not need to do any big bang approach for migration. And it's completely managed and is serverless. And it also supports the self-managed Kafka clusters with support of Kafka version 2.811 plus with SASL Scrum authentication. Whether the Kafka cluster is an on-prem, cloud, or in hybrid deployment, it will be supported. And it also supports other different third-party Kafka clusters as well. With that, I'll hand it over to Leonid and John to take you to the next part of the presentation.
Thanks, Shubham. Okay. So as we saw, there's various different flavors of MSK for different teams of different size. But what we find is that as teams scale with MSK, a new operational reality begins to set in. At a small scale, platform teams manually provision topics, ACL, schemas, and this is all fine. But at a larger scale, the same workflow becomes the delivery bottleneck, and three patterns emerge consistently. First is topic sprawl without clear ownership. Second is external access requests that the VPC model wasn't designed for. And the third is non-Kafka clients, so things such as browsers, mobile apps, IoT sensors, or partner APIs that need real-time data. And what I want to stress is that this isn't an MSK-specific problem. It's actually a Kafka protocol and deployment model problem. But it shows up sharply on MSK because the VPC isolation that makes MSK so secure also makes external access and networking project. The shape is consistent. Things that work manually at small scale become the bottleneck at larger scale, and three specific patterns drive most of the pain. So let's take a closer look at each. So topic sprawl and ownership. When the platform team becomes a gatekeeper, every topic, ACL, and schema change routes through this one team. And the common failures include wildcard ACLs that silently break tenant isolation, order privilege service accounts nobody audits, and orphan topics. I think everybody has seen things like topic payments, and then topic payments new, and then topic payments final. Now, Kafka has the correct governance primitives in place, ACLs, quotas, schemas, but what it doesn't have is the policy and ownership layer. And the result is that the platform team owns everything by default, while the security team resists new use cases. The mature shape of this is opinionated naming, pattern-based ACLs, and policy as code. But that's ultimately an engineering investment most teams keep deferring because there's always a more urgent fire to put out. Next, we have secure external access. So Kafka as a system was not designed to be exposed to a public network, right? From the LinkedIn days, it was designed to run inside a data center. And for this reason, MSK clusters are private by default, which is the right security posture. But the real world often needs things like partners publishing or consuming data to and from a cluster. SaaS or mobile apps outside of AWS that need access to real-time data. Hybrid and multi-cloud Kafka clients. So if teams are running workloads in AWS and workloads on-premise, they need a way to bridge the two. And ultimately, there needs to be an auditable and controlled access path for regulated data. And the usual paths each have trade-offs. So first is, if you go the VPC peering and the transit gateway route, this introduces networking complexity, and there's no per-client policy enforcement. If you go with private link, well, this is only AWS only, and it's one way. And then if you turn on public access for brokers, this loses the VPC isolation. And again, it presents this problem of exposing services or exposing brokers to a public network, which they were not designed to be exposed to in the first place. So ultimately, what's missing is a Kafka protocol-aware proxy layer that can sit at the edge, terminate external connections, authenticate clients, and forward natively to the brokers that can remain private on the back end. Anything else that you do is ultimately networking gymnastics. And then last but not least, in terms of the operational challenges faced by scaling Kafka teams, is supporting non-Kafka clients. So for many organizations, Kafka acts as the central nervous system that holds and routes real-time data across apps and teams. But as we know, not all consumers are Kafka clients. So they don't run on the JVM, and they don't speak the Kafka protocol. So for example, there may be web dashboards that process data over HTTP, SSC, or WebSocket. There may be microservices in the organizations that speak, for example, gRPC. If you're in the industrial manufacturing space, you may have IoT sensors and devices that use MQTT. And then if you have partner and you have external APIs, these most often are REST-based. So what happens today is every team builds its own consumer service API layer and auth middleware, which amounts to months of engineering per integration that's duplicated across teams with inconsistent governance. And this is where the operational problem becomes an application delivery problem. So protocol translation belongs at a gateway layer, not in end copies of bespoke middleware. So we've established that Kafka, particularly MSK, should have a dedicated operational layer with 4 key capabilities. The first is self-service access, which allows teams to discover, subscribe, get credentials without filing tickets. The second is secure external access via a custom domain with TLS, IAM, SASL, and TLS at the edge, allowing clusters and brokers to remain private. The third is a government and policy enforcement layer, which allows you to set topic policies, validate schemas, put producer and consumer guardrails in place that are enforced consistently. And the last part is observability. So getting visibility into things like per client usage, lag, errors, and access patterns. And the idea here is that an operational layer should complement MSK, same way an API gateway complements your service backend. The pattern is you have a Kafka native proxy at the edge with a control plane on top for governance. And so the critical point here is that this is additive. There should be no changes to broker configs, no changes to your IAM model. There should be no migration. Proxy sits in front, and MSK can sit in the back doing best what MSK does. So Zilla platform is an example of an operational layer for Kafka that we provide at Aklivity. The control plane, i.e. the console, on top is where governance lives. So this is where things like API data products are found. There's a self-service catalog. There's policy enforcement. There's observability across deployments. Underneath the data is a data plane, which takes the form of a Zilla gateway. That's the piece that speaks Kafka protocol natively on both sides and can expose HTTP, SSC, MQTT, and gRPC externally, and then interface that to Kafka on the other side. The data plane runs inside your own AWS account, and then the data plane and the control plane work together. So the console defines the policies, and the gateway enforces them on every connection. So we'll be showing the platform in action alongside MSK Express in the subsequent demo that John will be driving. But before we do that, let's take a closer look at some of the use cases and outcomes enterprise teams out there are achieving with an operational solution like Zilla and alongside Amazon MSK. So the first is Bader Bank. So Bader is a German investment bank that supports securities trading, market making, and banking as a service for financial institutions, fintechs, and partners across Europe. As a regulated financial institution, Bader needed to comply with Germany's federal e-invoicing mandate, which required secure, standardized real-time data exchange with external banking partners. The challenge was that Bader's core event-driven architecture runs on a private Amazon MSK cluster, while many partners still rely on legacy systems that could not directly connect to Kafka. So exposing Kafka brokers externally for Bader would have created security, compliance, and operational risk. And building custom middleware would have added cost, complexity, and long-term maintenance burden. So ultimately what Bader did was, by deploying Zilla, they were able to transform MSK event streams into an open API compliance REST API that partners could easily consume. So what's actually interesting is they took an existing open API contract that they were using prior to going in all in on an event-driven architecture, and with the help of Zilla, they mapped it onto MSK. So for their external partners, from their perspective, they were interfacing exactly with the same open API that they have been for years, but on the other side of that open API contract was in fact an MSK cluster. So ultimately, the result was regulatory compliance, faster partner onboarding for Bader, reduced middleware complexity, and a reusable integration layer for future mandates and partner connectivity needs. One other thing to highlight is another use case, another team within Bader is actually using the same gateways to stream real-time data from their MSK cluster to their to various mobile apps. And they're doing this by mapping MSK streams onto SSC, onto server-sent events. So with the same gateways that are supporting these external partners and providing these open API interfaces, they're also using them to stream real-time data down to mobile clients. Another organization that is reaping the benefits of having an operational layer on top of MSK is N Brown. So N Brown is a leading UK digital retailer with brands including JB Williams, Simply Be, and Giacomo. And they have an in-house financial services platform that's building out a buy now, pay later offering. So basically an Affirm type product that's built in-house. So providing credit to customers, enabling them to put something in their basket, and instead of paying on the spot, sign up for a payment over time plan. And to deliver a responsive customer experience with this digital product, N Brown's financial platform team group needed to integrate with third-party credit, payment, collections, and statement service partners using an event-driven connectivity pattern versus a traditional batch or REST pattern, because it needed to happen dynamically, and decisions around the creditworthiness of a customer needed to happen in real time as the customer was checking out a product. So the challenge was that N Brown's real-time architecture, like Bader's, runs on MSK inside a private VPC, and the security model that protects the Kafka cluster makes it difficult for trusted external partners outside of that VPC or even the AWS account to connect. And for N Brown, turning on public broker access would have undermined MSK security benefits, while custom networking and middleware would have added complexity. So ultimately, they deployed an operational layer with Zilla and created secure, publicly reachable Kafka endpoints behind a custom domain without exposing their brokers or making any changes to their underlying clusters. So Zilla ultimately handles the Kafka native proxying, TLS identity propagation, broker load balancing, and MSK ACL enforcement across N Brown's external partners. And ultimately, the result was faster partner integration rollout, reduced middleware development, stronger security, and a reusable foundation for expanding event-driven access across Kafka with future API-based integrations. The other thing that happened is, by having this proxy layer in place between N Brown's brokers and its external partners, they're able to decouple their clients, upstream clients, from their brokers, giving them more freedom to make changes on the server side without impacting the upstream clients. And last but not least, Kone is a global leader in the elevator and escalator manufacturing and services industry. So they operate a broad ecosystem of enterprise applications that depend on secure, reliable, real-time data exchange. Kone's challenge was connecting roughly 20 external apps and teams to MSK. And these apps included things like SAP, Salesforce, various mobile apps, monitoring systems, and even pip. So Kony's MSK clusters were again intentionally deployed in a private AWS subnet to reduce security risk. So exposing the brokers publicly was not an option. And Kony needed a secure way to support internet-based Kafka connectivity without compromising its private infrastructure or building and maintaining custom integration code for every system. So by deploying Zilla as a Kafka native secure gateway, Kony securely exposed its private MSK clusters to approved external consumers while keeping brokers isolated in private subnets. And Zilla is enforcing MTLS, it's supporting Kafka native access, and it's enabling multiple integration patterns across publishers and consumers. So the result is that was secure MSK access for Kony from anywhere, regardless of app and team, faster delivery for projects involving external data consumers, and reduced reliance on custom publisher and subscriber code. So Kony now has a unified, secure integration model for critical financial, supply chain, R&D, and operational data flows across its global ecosystem. So with that, I'm going to hand it over to John to get into the meat of it and show you all of this actually in action. So John, over to you.
So this is a very typical example of a deployment in production that uses the Zilla Gateway approach that Lena just mentioned, where we have, if we just take this from left to right here, we have external clients coming into a deployment of Zilla Gateway with a public NLB as the first point of contact on the network. That's using an NLB is very lightweight because it doesn't terminate TCP or TLS, just forwards the flow packets through to the auto-scaling group of Zilla gateways behind it, each one of which is stateless and forwards the protocol through to MSK Express, which is running in its private subnets. So that means that we can very easily scale out the Zilla gateways because they're stateless, and we can also handle failure modes pretty elegantly whenever there's a need to scale in, scale out as well. So that's a very straightforward approach that makes it easy for people to deploy this. So we're going to go through the traffic flow next. So the first thing that happens is that the client thinks it's talking to a typical Kafka cluster. So it's speaking the Kafka protocol, but it's actually reaching a custom bootstrap domain that resolves to where the NLB lives. And it makes the first point of contact to that NLB, which then flows through the NLB. That TCP connection flows through the NLB and arrives at one of the Zilla gateways. At that point, the Zilla gateway will terminate the TLS connection and make connectivity out towards MSK as well. And if enforcement of authentication is happening at the gateway directly, then we'll enforce there, including MTLS. And we optionally also validate the schemas for messages as the data flows through, as messages flow through towards MSK. And then the response path of data flowing back towards the client through the gateways, all on the same connections. So that means that from the perspective of the client, they just think that they're interacting with a cluster, and we're able to mimic the protocol in the right way so that it delivers these custom domain endpoints for it to reach, and then we're able to intercept, authenticate, and validate on the way through. There are absolutely no MSK config changes necessary in order to do this. Only one NLB is required to be deployed in front of the Zilla Gateway auto-scaling group. And this means that because there are no changes to the back-end MSK cluster, then anything that's connecting directly to the MSK cluster has no need to be impacted at all, doesn't see any change. And then clients, as Lena touched on earlier, that are on the outside of the gateway, they only see the custom domain, and therefore they're protected about any changes that you might want to make behind the scenes to the MSK deployment. Say you wanted to switch over to a different cluster behind the scenes. That would not make a change to the bootstrap domain presented for the custom domain to the clients. So there are two things that terminate at the edge, identity and also integrity. So identity is all about who's connecting. And so we have three different modes here. One is IAM, which is, as you know, I'm sure, the AWS internal mechanism for authenticating clients based on roles and policies for security, and we support that proxying through the gateway to be authenticated, authorized at the target MSK cluster. So we're still able to put the custom domain in place while that is propagated through. Also, SASL Scram, in case you are in the AWS ecosystem, but you have a non-AWS client, but the secrets are in Secrets Manager for that. And then for TLS, for mutual TLS, this is the best one for if you have external partners and you want to speak the Kafka protocol, because then you can have a cryptographic identity associated with each of your clients to ensure that only the authorized, identified clients are allowed to connect and participate in the cluster. Whenever data flows through the gateway, and we do things like validation, we always think about things in terms of streaming rather than buffering. We've put a lot of work into making sure that we have a minimum amount of aggregated data in the gateway as things flow through, and that allows us to go at full speed and maximum throughput, touching on some stuff that Shubham mentioned earlier about throughput of MSK Express. And we're activating all of those benefits too as it flows through the gateway, maintaining that very high performance and making sure that we don't have any latency overhead. It's very, very low latency flowing through the gateway. For schema enforcement of messages, to make sure that we understand the types of these messages, what they're supposed to be, we do first-class integration with the schema registries that you might already have. It could be Confluent Apicurio or AWS Glue as well. And that one's interesting because it has a slightly different API surface area for integration than a traditional schema registry, but they all behave as first-class citizens in the Zilla gateway when we're enforcing schemas. We do ensure that we enforce these schemas on both produce and consume. And so invalid messages are getting rejected before they ever actually arrive into the broker behind the gateway. So this is extremely helpful for making sure that we have the highest quality data inside the MSK clusters. They never see malformed data, but we are able to propagate the identity through the gateways to the MSK cluster so that we can continue to get a consistent sense of client identity that can be enforced for ACLs accurately. And also you get a consistent audit point for both identity and integrity. So we do a first-class integration with Zilla Gateway to many AWS specific services. It's probably worth calling out some of the work we've done here around Nitro Enclaves and ACM specifically. So ACM for public certificates that are needed by TLS for custom domains typically doesn't give access or discourages access to the private key for that server certificate. So that works well for AWS managed load balancers, for example, because that's an AWS specific system. But if you want to terminate TLS directly at your own software that's running in AWS, then you kind of need access to that key information so that you can properly terminate, complete the handshake for TLS. And that's what Nitro Enclaves integration gives us. So Nitro Enclaves is a way to run trusted code in your AWS execution environment, let's say in EC2, for example. And whenever we use the integration with ACM for that, the private keys are accessible indirectly through the Nitro Enclave. So we never actually see the private key. They never become visible to us, but we're able to kind of ask questions of the Nitro Enclaves during the TLS handshake that can only get successful answers if the Nitro Enclaves uses the key to answer them. And so that way we're able to integrate and complete the TLS handshake correctly using the private key in public cert, but without ever exposing the private keys to the rest of the system. We do integration with Secrets Manager for if you want to store your certificates there, and also for credentials for SASL. For CloudWatch, we were able to record metrics and logs and direct them there. In fact, in the gateway, we have a first-class concept of telemetry with metrics and log events that can be exported to any number of different systems, and Amazon CloudWatch is a first-class integration that we support. In AWS Marketplace, we have a product listing there for Zilla Plus, which is easy with one-click subscribe. And most teams get started with CloudFormation for that because it's easy to get going. And we also have first-class support for Terraform with CDKTF templates. You can deploy to ECS on Fargate, for example. And we have EC2 image for it as well, so we have full control on EC2. So, but it's not just about Kafka protocol. With Zilla Gateway, we're able to integrate a number of different protocols and effectively translate those protocols as those clients communicate through to the same MSK topics. So we have Kafka clients that we just talked about with a custom domain, but we can also have your traditional REST APIs and server-side events for streaming messages coming out of MSK through the gateway, talking to the same topics. We can also support WebSocket with MQTT to do IoT style clients, again, integrating and interacting with the same topics. Because you have a single way of connecting through the gateways to MSK, we can enforce the same schema validation in one place. We can put in per client rate limits, and we have one authorization service if you would like to have unified security across all these different protocols as they flow through and into MSK behind it. So with that, I think we'll switch over to the live demo part. So this is Zilla Platform. And in Zilla Platform, we have a number of different concepts that I'll explain. First one here is this concept of an environment where we're able to define different Kafka clusters that you might want to integrate with. So here we've already configured the different endpoints for MSK Express. And so we have the SASL Scram endpoint, we have the mutual TLS endpoint. So the brokers listed here, you can see these are on 9096 for the SASL Scram. And we can browse in here and see the topics and the consumer groups, for example. And we're able to take a look at ACLs and quotas as well. If I go back out, you'll see actually in the summary, you can see it's the same summary for both because they're actually talking to the same logical cluster, even though it's attaching through on different protocol approaches. So here is the same brokers listed, but this is port 9094, as you might expect. Then so that's sort of making the understanding of those clusters available to the Zilla platform as a whole. Then within this environment, we also have this concept of an endpoint that allows us to attach a custom domain and some other things too. So here we are in the MSK Express MTLS endpoint. And this is where we've put a custom domain, in this case, kafka.ems.aklivity.io. And this is on port 9094, but it could be on any port you like. This is an MTLS endpoint, so it has a staging CA that is being used as the certificate authority for all the client certificates that are presented. And here we've already provisioned a client certificate private key. So if you have privilege to do so, you can generate a client certificate here. What that does behind the scenes is it creates a private key in the browser and a certificate with your common name. And then behind the scenes, it goes off and signs that request remotely, gets the signed certificate back and downloads both to you locally. So that private key never left your local environment, but you've got a signed private key and public certificate that's available to be used with this certificate authority. I'll just quickly show you that the staging CA is actually integrated with AWS Certificate Manager Private Certificate Authority here. So at this point, I'd like to show you how this interaction works from the command line where we're actually going to use the information I just said. So that generated certificate and client cert are in these files. And here we're just going to consume from the orders created topic. You can see that the Bootstrap server here is kafka.ans.aklivity.io on port 9094. And here we're able, with this custom domain, to read all the messages from the Kafka topic. And over here, we're going to produce via MTLS as well. Now, the thing that's interesting about this is, beyond the fact that we have custom domain, is that MTLS actually very difficult to get working where you propagate the identity all the way through. And so that's something that I think is unique to us here at Aklivity with the Zilla Gateway, where we're able to propagate the identity successfully all the way through to the target broker, which means that the identity presented at the outside client, the external client, is the same identity that's presented through the gateway to the broker. And when it arrives at the broker, because that identity is intact, then the ACLs can be enforced accurately as if you were connecting directly to MSK on the internal domain. So if we just then go back here, so that's all about thinking of it from the perspective of more like an administrative view, where you're coming in on a custom domain and maybe you're producing, consuming. It feels like you're hitting the whole broker, even though it's on a custom domain. You might be wanting to create topics even. So we can see that you can attach a policy to this endpoint that allows us to put in some specific rules about what you're allowed to do and what you're not allowed to do. And there's an enforcement action here as to whether it actually gets blocked or just logged, which I'll talk about in a moment. So here's rules, the example of some rules that you can apply at the entire cluster level. So you can say what you're allowed to do with specific broker configs. You can say whether or not the client must present a client ID. So if they don't, then they just straight up get rejected. If you would like to do that, we can lock down different rules for the specific versions of the APIs, which can be helpful when you're trying to migrate forward and make sure clients are doing the right things. And we can even do a constraint on what compression is permitted by the client whenever it produces and consumes messages, because that has impact on CPU consumption, both during produce and also during consume. Then at the topic level, we can have naming patterns where we can say, for a specific named group of topics, we can enforce that the name must follow a specific pattern. So it can be more specific in this. This is just a wildcard. And then we can say things like, whenever you're creating topics that match that pattern, they must have a certain range of partitions, max and min, and whether you're allowed to increase it by a certain amount or not. Similarly for replication and configuration, and then also whether or not some topics you're even allowed to try to delete before you get it close to the broker. So you can see here that it's possible to create a policy that could define and enforce the rules that you would otherwise be forced to enforce at the operations team, and that this is allowing people then to interact with the brokers in an approved way, so that they're only doing the things that team wants them to be able to do. So then that's all about interacting with the cluster at the more administrative level. But then there's this concept of APIs. And so in Zilla platform, we take the concept of Kafka topics and turn them into what we call an API product, which you might be more familiar with in the REST world, where you have API catalogs that define your REST APIs. Well, here we have API catalogs that are defining not just REST APIs, but Kafka APIs. And so here we have an orders API that's described using a standard called async API. Async API is the sister specification of the Open API spec, or Swagger, that's used for REST. And it's a generic description that just always has support for all the different kinds of asynchronous protocols, including MQTT, including Kafka and others. And so this orders created channel in that terminology is actually, in Kafka terms, that's a topic. And then down here, we have the message for, let's say, orders created. And you can see that there's a definition of the fields here. We've got 3 fields, they're all required. And the last one is an integer. This is the definition of the orders API, and it's in the catalog. So now we want clients to be able to use that. So we have this concept of an application, which is representing your client process that might be connecting into Kafka to talk to these things. And you subscribe to specific APIs just as you would do in a REST-based approach. So you have an orders API subscription here, and we subscribe to that particular product. And we've got a custom domain entry point here for that API on port 9092. So what I'd like to do is just show you that in action. So we'll go over here, and whenever you subscribe to the API product, so it has a particular security mode. So we demonstrated MTLS earlier, and we do support that also for API products. Here we're also capable of showing you the API key approach. So I've got a username and password with an access key and a secret key, and we're using SASO Plane to connect through to the gateway. So in the setup, the consumer here, you can see that it's hitting the Bootstrap server on that exact custom domain that we talked about earlier. And this is on port 9092. And then that's going to show messages that arrive after I produce here. So this one is is echoing this message at the top here. You can see the timestamp ends in 1 there. And it's a Kafka console producer hitting the same custom domain and hitting the orders created topic. So as I produce in here, then you can see that it popped up here. It even popped up actually in the left before this one finished deploying. So I'll just do another one here. Yeah. And so what I'm going to do now is I'm going to attempt to produce a message that is not valid by the schema definition in the API product that you saw earlier. So I just removed the timestamp field, but we saw that all the fields were actually required. So if I try to do this produce here, you can see that we're getting an error coming back, and it says invalid record, and it failed validation. So the broker, and it's rejected. That means that there's no message in the broker, so the invalid message did not actually arrive, and therefore it didn't show up on the left side here. And so if we just go back and do one more good one, you can see that this is bookending the attempt to do the invalid message, and therefore we can see with certainty that it never actually got the invalid message in the system. So this is API product access to the Kafka broker through a restricted set of topics as defined in the API specification. But as we mentioned earlier, Zilla also supports other types of protocol access into Kafka. And so here we have a browser-based application that can use server-side events and can also use REST to publish and subscribe. So what I'm going to do here is just hit subscribe here, and you can see that those messages came in pretty quickly, all coming from the same broker topics. And so if I produce here, I'll just make this sort of obvious that this is coming from here. And you can see that that comes in immediately. Now, one thing I want to point out about the standards that are being used here is that this is using something called server-side events, just reloading the page so that the network tab can kick in when it comes. And I've got fetch XHR selected here, so we didn't see all the other resources load. But when we click on the subscribe button, you can see this orders created request came out of the browser, and it's actually an event stream, a first-class event stream. And so all these messages that are coming in are following the server-side event standard. And as I produce another message, you'll see that it pops up at the bottom here automatically. So one of the benefits of using standards to do these integration points is that you're able to take advantage of all the other things that integrate with the same standards. And this browser-based development view is just one example. So when I look at the orders created here, we're able to see that this got a 204 no content response, and the payload that was sent is exactly what we saw up here. So everything's round tripping through the browser, through the gateway, to the broker and back out again down to the SSC layer. All right. I think that's everything, Leonid. So I'll just go back to here and then let's go over what we just covered. So this is there's a lot going on there, but in terms of what we're able to do, but the actual requirement on deployment is deliberately straightforward, right? The gateways are all stateless, so it's easy to scale them out as you want to cover more load. You've got your public NLB and your custom DNS, letting the MSK piece completely stay private behind the gateway cluster. The clients are isolated from any MSK specific configuration. So they have their custom bootstrap server and they're able to present their credentials in whatever mechanism you would like. And it's terminated that edge authorization authentication is terminated at a gateway where that makes sense to do so. We have a lot of AWS integration in play, including ACM and Secrets Manager. And we talked about Nitro Enclaves and CloudWatch for monitoring as well. The multi-protocol aspect is most interesting because that's actually all done with declarative configuration for the Zilla gateway, and it allows you to, in one deployment, handle any number of different protocols that you would like and integrate them together seamlessly against the same backend MSK topics. So really what's left is to understand, better understand how that applies to your particular situation where it matches with these patterns. And I think that's what's next.
Okay, yeah. So that was the demo. We covered everything. So in terms of how to take advantage of all of this, there's three paths from here. One is you can deploy the gateway that you saw, the Zilla gateway, on its own, and it's available on Marketplace. If you want to do things like the Kafka proxying and you want to expose your MSK cluster via a gateway/proxy, you can go to the Marketplace and search for Zilla Plus for Amazon MSK. We also have an open source version of the gateway that has some of the capabilities of Zilla Plus. It's able to do things like protocol translation, so it can map REST, SSE, and MKTT to and from Kafka. It doesn't have Kafka native or native Kafka client proxying capabilities. That's only available in the commercial gateway. And then there's Zilla platform. So the platform contains a Zilla Plus gateway. So all of the capabilities of the commercial gateway are found inside the platform. And then you also get the console, you get the management control layer on top, which you saw in the demo. So if you're interested in the platform, please reach out to us directly. Either shoot a note here in the chat, or if you go to our website, you can find multiple ways of getting in touch with us. And we will be happy to chat through and go into detail on the platform and how you can take advantage of it. We hope to see you on the next ones. And again, please follow up if you have any questions, either for anybody on the Aklivity side, for either myself or for John, or reach out to Shubham if you have questions on regarding MSK.